This next clip, it's a motion problem where we have two linear equations that are equal to the same thing. We will reformulate until we get translational symmetry, and then from one-to-one matching, we'll solve the problem. A powered catamaran took 3 hours to make a trip downstream. The return trip took 5 hours. There was a constant 6-mile-per-hour current. Find the speed of the boat in still water. Going downstream, I have this speed in still water, S plus 6 miles per hour. And it took 3 hours to make the downstream trip. So this is velocity times the time, and that'll give us the distance. A return trip, the speed in still water, minus 6 miles per hour current, bucking the current. So it's going to take us 5 hours to do the trip, same distance. I'm going to do this multiplication, 3 times s and 3 times 6, here it is. Distance equals 3s plus 18. And I'm going to do this calculation, 5 times s. 5 sixes minus 30. The first thing I want to do is match that minus 30 up here. So I'm going to subtract 30 and add 30. 30 and 18 is 48. Here's the minus 30, and that's 18 plus 30, 48. On this one, I want to reformulate this 5 times the speed in still water. I'm going to subtract 2s from that and add 2s. When I subtract it, I get 3s. And when I add it, here it is over here, 2s. So I have translational symmetry. The visual solution is twice the speed in still water is equal to 48. At that point, you could write a 2 in front of that and put that in parentheses and then divide by 2 to match that coefficient. But I wrote it down here. 2 times the speed in still water equals, I have to match the coefficient 2, so I'm going to multiply by 2 and divide by 2. And when I do that, I get 24. 48 divided by 2. So the speed in still water is 24. This is an alternative method for solving the problem that we just did. Here's the fundamental equation. Distance equals velocity times the time. The speed in still water will be increased by 6 miles per hour because of the current when you're going downstream. When you're going upstream, the speed of the boat in still water, we have to subtract 6 miles per hour. So consequently, it takes 3 hours to go downstream and 5 hours to go upstream, and it's the same distance. So we can equate this to this, and I'm going to multiply it out. 3 times s, there it is. 3 times 6, 18. 5 times s, right there. 5 times minus 6, minus 30. Now we're going to solve by constructing a symmetrical equation such that when it's added to the asymmetric original equation will yield translational symmetry. The first thing I'm going to do is add 2s to 3s to match that 5. So that's 5s. And then I'll bring that 18 down. I'll bring this 5s down. I have to add to minus 30 a number such that the result is 18. So I have to add a plus 30 plus 18. Plus 30 plus 18 is 48. So I'm going to add, when I add 48 to minus 30, I get plus 18. I have translational symmetry. Then I have to reformulate 48 because of that coefficient. 2 times S equals 2 times 48 divided by 2. When you multiply by 2 and divide by 2, that's the same as multiplying by 1. So S, when you do this division, is equal to 24 miles per hour, the speed in still water. And this is the unique solution. I don't have to test it back in the original equation, because when I add this symmetrical equation and it gives me translational symmetry, then that is the unique solution. In the next clip, we'll do another simultaneous equation with 2 variables. This is a problem that's going to involve 2 variables, x and y. There are 2 supplementary angles of which one angle is 12 degrees less than 3 times the other. What is the measure of the angles? Angle x plus angle y equals 180. Supplementary means the 2 angles add up to 180 degrees. Complementary means the 2 angles add up to 90 degrees. So we have 180. Here's the second equation. Y is equal to 3 times the other, 3 times x. 12 degrees less than means minus 12. So I'm going to reformulate this one first. I notice that minus 12, so what I want to do is add plus 12 to 180 and then subtract 12. So I do it. When I add 12, I get 192, and there's the minus 12 to bring us back to 180 again. So I'm going to match that. Then there's a y on this left-hand side, and there's an x on this left-hand side. So I want to match that. What I'm going to do is add x to both sides. X plus y equals x plus 3x minus 12. This is going to be 4 when I add it. X and 3x is 4x minus 12. So I want to reformulate 192. I'm going to multiply by 4 and I'm going to divide by 4. When I do that, I get x plus y equals 4 times 48 minus 12. And then rewrite this equation. X plus y equals 4x minus 12. So we have translational symmetry. So x is going to be 48. Everything matches. I have x equal to 48. I'm going to put it in the first equation. 48 plus y is equal to 180. Then I'm going to reformulate 180. I'm going to subtract 48, and I'm going to add 48 to 180. When I do the subtraction, I get 132. So y is equal to 132 degrees.